What's up, YouTube? It's your boy JOHHABRAHAM. We're back with the thermodynamics presentation. I got the presentation in like 30 minutes. 30 minutes. 15 minutes. So boy, I'm pretty scared. I'm not I wouldn't say scared, but you know, it's a presentation in front of some people. Yeah. I hope I don't fumble. I don't fumble too much. New setup. The laptop screen is now on the left, so whenever I'm on the left, I'm looking at the laptop screen. Just kinda annoying, I know. I know. There's a slight change in change in the date. Yeah, I need to make that change. The- Thermo. Where is thermo? Yep. Open, open the chat. God damn it. God damn it. I have already answered this question from the assignment or from the what? For the assignment. And today I would presentation and I feel like this question has a lot to explain compared to the others with just equations. Zeroth law, yeah, first law. Air leaves your body with kinetic energy. Moving air collides with surrounding air molecules. Organized bulk motion gradually disappears. Organized bulk motion. Bulk movement of fluids versus the first law. Oh, right now we consider air as fluid. Kinetic energy is transferred through collisions to surrounding molecules. Bulk kinetic energy, random molecular motion, internal energy. It is spread across many molecules. Okay. So it's a bulk of air molecules flowing in a specific direction, which means kinetic, or I should write like this, right? Means kinetic energy which affects the surrounding air molecules collides with surrounding collides. Gotta start again. The system A is in thermal equilibrium with system B, and system B is in thermal equilibrium with system C, then system A and C are also in equilibrium, also in thermal equilibrium. If your thermometer is in equilibrium with water, it's calibrated against other thermometers. They indicate the same temperature. You know what? I don't want to talk too much on that. Oh, I gotta talk about that. Temperature is a measurable property first law. Energy cannot be created or destroyed, only transferred or converted between forms. Only transferred or converted between forms. I'm looking at my laptop screen again. Damn, you got me. Change in internal energy equals Q plus W, heat produced plus work done. Total energy is conserved. Second law. Entropy of an isolated system tends to increase over time. Entropy of an isolated system tends to increase over time. Example of an isolated system, the universe itself. The universe itself. So, equal to greater than 0. Natural processes move towards third law. The entropy of a perfect crystal approaches 0 as temperature approaches absolute 0 as in 0 Kelvin. at 0 Kelvin, one accessible microstate. Fuck. I got 14 minutes. 14 minutes if I hit the glass. Puff of air and first law. I did have an answer, right? Nope, not the photos. Notes. So, for part B, when you blow a puff of air, the air molecules are moving in a specific direction. So it's having a kinetic energy and it collides with surrounding air molecules which does not have this specific kinetic energy on a specific direction, which does surrounding stationary air molecules not have motion in a specific direction, rather random. Which does not have motion in a specific direction, rather randomness, or motion in a random direction. So when these surrounding air molecules so it collides with the stationary air molecules and changes the kinetic energy to which results in random molecular motion or increase in random molecular motion, which is increase in internal energy. Increased internal energy, what else? and it still follows the first law of energy. Here energy is just converted. uh, as the moving air slows down, its organized kinetic energy is transferred through collision and surrounding stationary air molecules to surrounding surroundings stationary. Okay, stationary. Molecules where it becomes distributed as random molecular motion. Distributed as random molecular motion, which is basically increased internal energy or thermal energy. Five more minutes? God damn it. Thus the first law of thermodynamics is obeyed, as the energy comprised in the bulk of air is not destroyed, rather converted. Air moving in specific direction Maxwell's demon appears to violate the second law. Okay, that's good enough. Usually the most interesting presentation topic. Oh, fuck. So Maxwell's demon. So according to Maxwell's demon, there is a system with two chambers, and each of the chambers are having molecules of different pace, and what they're saying is a demon basically separates slow moving molecules to one side of this chamber and fast moving to the other side without no work being done, or it opens fuck. It separates fast moving and slow moving molecules without any work done on the system. So it's gonna look like system with one side only having fast moving molecules, and system on the other chamber it's only slow moving molecules. Okay, I need to drink a little bit water. Seemingly allowing heat separation without energy input. So basically the chamber with fast moving molecules are hot and cold. Heat separation. This creates a heat separation within the system without any work being done. And in the case of entropy, one chamber has only fast moving molecules. That means lesser possible microstates. Lesser possible microstates means lower entropy. So basically a system just went from a particular number of entropy to lower entropy. Entropy, which is only possible if external energy is applied to the system, but the demon is not doing any work. It sounds like a demon. Well, yeah. So this is breaking the second law of thermodynamics. As the Okay, YouTube, it's time. It's about time, YouTube. I'ma end the stream. Yeah, it was nothing, right? 30 minutes, yeah. Well, I'ma end the stream. I gotta hit the class. Peace.